Hey guys, you've gotta know this tool. It's free open source monitoring tool that you can use to monitor anything from websites, services, Docker containers hosted anywhere in the cloud, in your home lab, and when the service is down, with that tool you will receive a notification in whatever distribution channel you choose. It has a tons of offerings from Slack, Discord to Telegram, so stick around and I'll show you how to set it up for free. And this is how it looks like when it's deployed. In my case, I have a website that I self-host on the Raspberry Pi at home. And with that come all the issues that you get when you choose a self-hosting journey. The main one is limited availability. When there is no electricity, no internet, or there are issues with the Raspberry Pi itself, the website is down. And in these situations, I would like to know when it happens as soon as possible so that I can address these issues. Here I have my website. I have set up Uptime Kuma yesterday, and if I choose 24 hours, you will see that today in the night something happened. It went down around midnight and came back up only around 6 am. Obviously I was sleeping and couldn't do anything about that, but Uptime Kuma did its job very well, and when the website was down, I have received a notification in the Telegram, and when it was back up around 6 o'clock, I also received a notification. Let's look at our options on how we can deploy Uptime Kuma for $0, absolutely free. For that we have two choices. The first option is super obvious one. We can deploy Uptime Kuma locally on our old computer or Raspberry Pi or whatever device you have to host it, and then you'll be able to monitor whatever in your home network, your websites, your other services, your other devices that you run and you want to check that they are online. And yeah, so this is our first option, deploy Uptime Kuma locally. But the second option, and the one that I prefer more, is to deploy Uptime Kuma in the cloud. And yes, we can do it for $0, absolutely free. I prefer cloud deployment option because it objectively offers greater availability than what you can get from your home lab. Since it's a monitoring service whose primary goal is to check other services whether they are up or down and notify me as soon as the issue happens, it makes no sense to host it at home, because if I have some issue here, no internet, no electricity, then the monitoring service will be down as well. So for Uptime Kuma, I want it to be as available as possible. That's why the cloud is my choice. Gemini says GCP offers one E2 micro VM instance per month within its always free tier, and this will do for us. We need to follow certain rules for that, like select this type of VM in any of these regions, storage is stopped at 30 GBs and only 1 GB egress. But I think this will be sufficient for our use case where we will be the only user of the monitoring service. Now let's create this VM. Sign up for GCP if you don't have an account there. They offer free tier. Everything should be for free here if we do everything correctly. So I'll search for VM instances. We will need to enable Compute Engine API. Once API is enabled, let's go to Compute Engine and create an instance. So create instance. Close it, let's give it a name, but I'm fine with the default name. We have a set of regions to select from. I think US Central will do, but I'll select US East 1. For zone, I don't care, let's leave it any. And here is a crucial part, we need to select the correct instance, the one that's within always free tier. So it's E2, low cost day-to-day computing. Then in the presets, very important, let's select E2 Micro. Great. In the advanced configurations, we don't need to change anything. Then let's go to OS and storage. The default size is 10 GB, but we need to use standard persistent disk, which will be HDD. I don't really care for that service, so let's select it. I think it shows you calculations regardless whether it's free or not, but I think it should be free in the end, despite the fact that it shows us these calculations. I think it shows it by default. Then in data protection tab, let's select no backups, just to be sure that we don't have any unexpected charges here. In the networking tab, let's enable allow HTTP traffic, allow HTTPS traffic, and for now that's it. For the host name, let's give it a name, monitoring service.service. IP forwarding, in our case, we don't need to enable it, but if you were to set up, for example, your VPN connection with WireGuard from your local computer to this instance, you should enable it. But in that case that I'm going to show you, we don't need it. Then below in the network interfaces, let's click on default, scroll down, and just to be sure that we don't have any charges, I'll select the standard networking tier. I'm not sure if it would impact anything or not, but to be on the safe side, I would suggest you to do the same as well. And click done here. In the observability tab, I'll remove the ops agent. Again, to be sure that there are no extra charges. You can leave it if you want, but I will not. In security, we don't need to change anything, I think. In security tab, leave everything unchanged, and in advanced, the same. So we are ready. It gives you a monthly estimate, but based on my research and from what I read, it shows you these calculations. But in reality, because of the rules of always free tier, it should be free as long as you have one VM of the correct type, of the correct storage, without extra charges. It should be free. At least I hope so. And let's click create. All right, our instance is created, and let's go to compute engine again. View instances. Why do you always redirect me to this API thing? I don't get it. There's just something wrong with the TCP itself. I hate this TCP. I'm sorry. I use the TCP call, but UI is far from perfect here. So I'll try it like this. No, damn it. Shit, it doesn't show me the VM instances. This is stupid. Yeah, literally, it always redirects me on TCP. I think that is enabled anyway. Oh man, this is ridiculous. Finally. I hope it behaves normally for you. If not, you can click right here. Number of VMs 1, and it works like this. This is super stupid, but it should work normally for you, I hope. So this is our instance, and let's open it. You get all the information about it, and now let's install Uptime Kuma. So let's click SSH here. It will open a new browser tab and connect to this VM in there. We need to authorize it, and we are in. We'll run Uptime Kuma in the Docker, so first we need to install it. So Docker install Debian, and here you'll get all instructions on how to set it up. So let's follow it. So I'm gonna install it with apt. Copy the first thing, paste, install the Docker and all the dependencies here. Yes. And it's done. So let's check that our Docker is running there. Docker ps. And we have to do it with sudo docker ps. And it's working. There are no containers running, but we are ready to run Uptime Kuma. So if you open the official Uptime Kuma website, you will see just one command here, and this is the command that we will use to run the service. Yes, it's that simple. So we copy the command, we paste it to the VM SSH terminal, and again, yeah, we need sudo here. Sudo docker run. It's gonna pull the image and set everything up. And it's done. So if I do again sudo docker ps, we see that the thing should be running. Yes, it's up and it's healthy. So it exposes port 3001, and we will access our service using that port. So let's go back to GCP Compute Engine here, scroll down, and in the network interfaces you will see the external IP, and we will use it to access our service. So open a new tab, external IP colon 3001, and at this point we will not see our website. As you can see, the website is loading, but actually it's not gonna load right now, and it's perfectly normal. And if I were to pin this IP address right now, the request would time out, and this is actually what will happen with our request from the browser a bit later. Why is it normal? Because when you create a VM instance in GCP, by default, due to security reasons, it's not accessible to everyone in the open internet. It's only accessible within your GCP infrastructure, and it's actually good. I'm gonna show you how to overcome this issue for our use case. We will not open our website to everyone in the internet because first, it's not secure. Second, we want to limit the traffic to our website as much as possible because we want to stay within this free tier, which offers us only 1 GB of egress. So because of that, we will limit the IP addresses that can access our VM to only my and yours IP address. For that, we will need to create a firewall rule, but first we need to add a new tag here. So let's click edit the VM instance, scroll down to network, and let's add a custom tag here, monitoring service. We will use that tag in our firewall rule. Click edit, and once it's saved, we will create a firewall rule. It's done, so let's search for firewall, and we will need to create a rule, not a firewall policy, but firewall rule. Click on it, let's give it a name, Uptime Kuma access. Here, don't change anything, the network is default, priority 1000, the default one is good with me. Direction of traffic ingress, meaning the traffic that will be coming to your VM and not from your VM. Action on match allow, and here specified tags, and we will specify here the tag we added to our VM, monitoring service. This rule that we are now creating will apply only to VMs that have this tag. So our one and only VM. Here leave everything by default, IPv4 ranges, and we will need to specify our IP address. Let's open Google and write what is my IP. Open the first website, copy your IPv4 IP address and paste it here and add a mask or leave it as is. And here in protocols and ports, specified protocols and ports, TCP and port 3001, because Uptime Kuma is running on that port. And this is it. Click create. The rule is created, it's right here. And now if we did everything correctly, it works. It works. Let's create our admin account. Great, we have Uptime Kuma up and running. We can configure anything right now, and it's secure and accessible only from our specified IP address. Let's set it up then. Click on add new monitor. First thing here, we have monitor type. You can click on it and it gives you a huge drop down basically with all the things that you can monitor. Group HTTPS, TCP port, pin, HTTPS with keyword, Docker container, whatever. My goal here is to monitor website. So for that, I would choose either HTTPS or HTTPS with keyword. I would choose the option with keyword. It means that it will check that the website is not just loaded, but it will search for specified keyword in the website page. It gives you like more reliability because you are sure that the website actually gives you the content and not just 200 status code. Friendly name, I'll give it typical language range web because it's the name of the website. Let's copy the URL here. Great, and then the keyword that we want to search for, I'll search for language range. Cool. Heartbeat is the amount, the time frame within which the Uptime Kuma will pin your website. Let's make it more often, just for the testing purpose. I'll give it every 30 seconds. Amount of retries, so it's the amount of retries that the Uptime Kuma will try to get the content before it sends you a notification. I'll leave it as 0, or you can set it to whatever value you want. Heartbeat retry interval, I'll leave it as a default 30 seconds so that it matches the default interval. Request timeout is how long Uptime Kuma will wait for the response from the server. I'll leave it as 24 seconds. Resend notifications if down X times consecutively, I'll leave it as 0 for now. Here in advanced options, we can enable certificate expiry and notification. So if your HTTPS certificate expires, you'll also get a notification. I'll set it as true, as ticked. Ignore a TLS SSL error for HTTPS website. You can either enable it or disable it. I'll enable it. Max redirects speaks for itself how many redirect requests Uptime Kuma will accept as a normal thing. I feel like 10 is too much, but I don't really care. Alright, let's set it to 3, for example. Accepted status codes, the status code of the server response, 200 and 219, between 200 to 99 is what we want for this type of thing that we are testing here. I have no group here, no description, and no tags. If you want, you can add it. Here on the right, we can set up a notification, which is great because without the notification, in order to know that something is wrong, you would have to check out Uptime Kuma, which is not like the main workflow, how it works, how it should work. So let's click Setup Notification. You have a bunch of different types here. I'll go with Telegram. You also have Slack, Discord, whatever. So many services, Signal, everything. I'll go with Telegram. I'll leave it a friendly name. Then we need to get a token from the Telegram bot father. You can click on the link. It will open you a Telegram app, and it will give you a token which you'll need to copy. It's a secure token, so don't show it to anyone. And I give it a token here. Then we need to give it a chat ID, basically your chat with you. For that, after you pasted the token, click on the link, and here you will see your ID. Copy it here, and this is it. Let's click save. Notification is in place. In HTTP options, you can test different methods, but for our scenario, we want to test get method. You can also set body headers for other types of what you expect to receive, but that's not important in our scenario. And click save. And once we saved it, you can see the first one was successful. The first heartbeat was successful, and after 30 seconds, it will try again. After 30 seconds, it tried again successfully. Let's try to get a negative response here. For that, I'll just specify the URL that doesn't exist and click save. And in the Telegram, as you can see, we got a notification that the service is down. If we correct the URL and save it, it should work again. So yeah, as you can see, the latest is successful. And if we try to search for the word that does not exist there, we should get an error, as here keyword was not found. And it gives you the message that the response was okay, but keyword is not in the given list. And with that, we are done. Now we have our monitoring service running securely and reliably in the cloud, and when something goes wrong with my self-hosted website or with other services, I receive a notification and I'm able to resolve issues as soon as I know about them. I hope it was helpful to you, and follow for more content like this and check out my other videos. Thanks for watching and see you in the next one.